Welcome to Homework Lib.
Hi, so over here we have a particle that has a charge of 2.3 microcoulombs that is going from point A all the way to a point B, traveling a distance of 0.27 meters. And we know that the particle experiences a constant electric force and its motion is along the line of the action of the force. This allows us to directly write down, remember that the magnitude of the force is equal to Q times the magnitude of the electric field, and we know that the electric field is related to the change of electric potential by the following equation minus the root of the potential with respect to position in this case. In this case, since we have a one-dimensional problem, I'm going to state it as x being our only dimension that we have at hand. And over here, we're given the difference in between the electric potential at point A and at point B. If you notice, this quantity is going to be equal to minus delta B. Remember that delta B would be equal to electric potential at the final position would be B minus electric potential at the initial position. That would be point A. In this case, just to keep the notation, it would be EPE at B minus EPE at A. So the value with the negative sign corresponds to electric potential at A minus electric potential at B. Now, in terms of the units, remember that 1 volt per meter is the definition for 1 Newton per coulomb. So with this, we can directly find what is going to be the magnitude of the force, because we can get magnitude of the force is going to be equal to Q times, in this case, since the electric force was constant along the movement, we can directly write down, instead of the derivative, we can take delta B over delta X with a minus in front of this. So with this, we can get the magnitude of the force. Notice as well that this would be the magnitude of the electric field. Just to be extra thorough about it, how we got to this expression is essentially by integrating the Ex dx equal to dB with a negative sign. We integrate both sides from, in this case, point A to point B, and from point A to point B. So this would be minus difference of potential, minus delta B. And in this case, since the potential on E is constant, this is Ex times position of B minus position of A, which is delta X. So from here, the potential would be equal to minus delta B divided by delta X. Okay, so first of all, the magnitude of the electric field, just to give the result from the problem, is going to be equal to difference of potential, 7.9 times 10 to the 4, times 10 to the minus 4, minus 4 joules, divided by delta X, which is 0.27 meters. Is going to be 2.926 times 10 to the minus 3 newtons per coulomb, or volts per meter. Both of them are correct. And finally, the magnitude of the force, which we said was Q times the magnitude of the electric field, is going to be equal to 2.3 times 10 to the minus 6 coulombs. Remember that we have microcoulombs, multiplied by the magnitude of the field, 926 times 10 to the minus 3 Newton per coulomb. So the magnitude of the force is equal to 6.729 times 10 to the minus 9 newtons, or approximately 6.73 newtons. So that would be all. The magnitude of the field is this one, and the magnitude of the force is this one. So that would be all. Thank you very much, and have a good one.